Okay, so today I'm going to be talking about how to factor out a binomial factor. And this is something that you do when you actually do factoring by grouping and factoring using the AC method. So first off, just what exactly is factoring? So we do need to know some definitions. We've got the word factor. So a factor is a number or quantity that when multiplied with another produces a given number or expression. Basically, if you have numbers that multiply together, like 2 times 3 gives you 6, 2 and 3 are factors of 6 because they divide evenly into that number. So factoring means we're reversing multiplication or the distributive property, multiplication of polynomials essentially, and we're taking the thing that's been multiplied out and we are now writing it as things multiplied together. So you're writing a product of factors. So you usually have a set of parentheses multiplied by another set of parentheses. So the very first step when you're factoring is to factor out the GCF, which is called the greatest common factor. And this is the largest thing that you can divide out of everything without resulting in a fraction or basically having a remainder. So when you have numbers, the greatest common factor is the largest number that goes into all of your numbers evenly, or you have no, doesn't give you a decimal when you divide it out. And when you have variables, it's the one with the smallest exponent. So there are two methods for factoring out the greatest common factor. Method 1, which is what the textbook uses. You first, for both of these, for both method 1, method 2 is my method. Your first step is the same. You're identifying what is your greatest common factor. It's step 2 and step 3 that it differs. So for method 1, step 2 is you're rewriting everything you have as factors multiplied together, and then you basically undo the distributive property. I find that a little difficult to follow. It's hard to do. So instead, I suggest, and this works really well for binomial terms, is rewriting it so you have your greatest common factor in front, then you have your parentheses, and you divide each term by the greatest common factor. And then you simplify inside the parentheses. I find that a lot easier than doing method 1. So since we're going to be focusing on factoring out binomial factors, we need to know, well, what does that mean? So a binomial factor is where you have more than one term. So binomial factors are generally surrounded by parentheses, and then they have things inside them. So for example, you might see x plus 2. That is considered a binomial factor. Binomial means two terms, so we're looking at specifically factoring out sets of parentheses that have two terms inside them. And this is basically what we do when we factor by grouping and then when we use the AC method. So all of this is going to make a lot more sense with examples. So the first example here, we want to factor out the binomial factor. So technically we've got two terms here, because if you have things multiplied together, those are still considered one term. So we have 13 times a plus 6 as a single term, and then we have minus 4b times a plus 6 as the second term. Within each term, there are two factors. So the things multiplied together, those are each considered factors. So like the first term, let me actually switch that to different color. 13 is a single factor, and then a plus 6 is another factor. And the a plus 6 is parentheses, so that whole thing is considered together. In the second term, we have 4b as a factor, and then a plus 6 as a factor. So we have something with two terms, and then within each term, there are two factors. And one of those factors is considered a binomial factor because it's got a parenthesis with two terms inside it. So I'm going to highlight the binomial factor here. It's the a plus 6, and then we have the parenthesis with it. So that is the binomial factor. And they both have that in common. So that makes it a common factor. So that's where we get greatest common factor. You're factoring out things that are in common, and they both have an a plus 6. So by factoring that out, we're basically removing it from those two terms, and then we're rewriting it differently. Now, in order to do this with my method, and this is a good practice for any kind of factoring that you're doing, always write any subtractions you have as adding a negative. So that would be step 1 is we want to, if I can get my pen, step 1, rewrite subtraction as adding a negative. And so that's going to give me 13 times a plus 6. I almost wrote b, a plus 6. And then instead of minus, I'm going to write that as adding a negative 4b times a plus 6. And the reason why I do this is it works really well for my method of factoring. So next is we identify the greatest common factor. And so that in this case is the a plus 6, because they have that in common. So that's what I highlighted. They have a plus 6 in common. And so this is where we're going to rewrite it using method 2. We're going to rewrite it as the greatest common factor, and then in parentheses, each term gets divided by the greatest common factor. So I'm going to just write method 2 here. So what this means, so we're putting our greatest common factor, a plus 6, in front. And actually, let me just keep color coding that so that I'll highlight it here. And let's color code. So we're going to have a plus 6 in front. And then you have parentheses. And then you have each term. So we have 13 times a plus 6. And then I'm going to put a plus. And then minus 4b times a plus 6. And then each term gets divided by that greatest common factor. So, and let me just keep highlighting that a plus 6, because that is what we have in common here. So what you see, especially when it's highlighted, is that basically the a plus 6 is going to be canceled out in each term here. Because we've got a fraction, we've got it on the top and the bottom. And so I can basically cancel out those a plus 6s. I'm removing it from these terms. And the reason why I did plus negative 4 instead of keeping that minus is just you always want to write your terms as adding in between your things, especially sometimes you're factoring out a negative and then that's where errors can happen. So you want to make sure that you have just pluses between terms as much as possible so that you know where your negatives are. So we rewrite and then we simplify, and the simplify is basically you start canceling things out. Simplify does not mean multiply together. So we're not going to be multiplying things back through, we're just canceling things out. So I'm going to just write that, don't multiply. So we have this a plus 6 in the front, and then we have a parentheses, and then we have 13, because everything else canceled out, plus, and then we have negative 4b, because everything else canceled out. So you can see that what happens is you end up with your greatest common factor in front, And then basically everything that wasn't a greatest common factor is in the back. So if I highlight with a different color the things that were in front, we had a 13 and a negative 4b. And then I continue that highlighting here. Those end up in your second set of parentheses. So what happens when you're factoring like this is you're generally going to end up with two sets of parentheses, two factors in the end. Your first one is going to be the greatest common factor, and then the second one is going to be basically whatever you have left over when you factor that out. So let's see, good way to write this. I guess you're going to have your GCF in some set of parentheses, and then I guess I'll just write leftovers. That's sort of what is going to happen when you are factoring out a binomial factor. And basically most factoring is going to end up with something like this, where you're going to have two sets of parentheses, and what's inside those parentheses depends on what you're factoring out, but you're always going to sort of end up with two sets of parentheses here when you're doing this kind of factoring. Once you go into college algebra, there is more factoring that you do, where sometimes you end up with more than two. You'll have 3, 4 sets of parentheses, but that's mostly when you're dealing with polynomials of degree 3 or higher, which you're not going to see in this class. So that's what we're doing when we factor out a binomial factor. So I recommend kind of color coding so you really see what's going on here. And you can see where all of the pieces end up in your answer. And if you kind of follow the color coding, then you can do a lot of this in your head because you see the pattern and you don't even really have to write down all the steps that I've written down. So here's a second example. We're factoring out the greatest common factor. Now notice our previous one said to factor out the binomial factor. Here we're factoring out the greatest common factor. It's telling you to do the same thing because our greatest common factor is a binomial factor. So you can see that what we have in common here in parentheses is the same. It's the x squared plus 1. So that greatest common factor is indeed a binomial factor. So the directions are slightly different, but it means the same thing. So that's really important. And so I'm going to just do the same kind of color coding here so that you can see we've got basically two pieces. We've got the 6 and then the x squared plus 1, and then you have a minus y and then x squared plus 1. So first step is to rewrite that minus so that it's adding a negative. And I am accidentally in the highlighter. Okay. 6. Oh, now I'm in black. Okay. So I'm going to just, let's see, I'm going to try to do these in the middle and line it up nicely. Then we have x squared plus 1, and then instead of minus y, plus negative y times x squared plus 1. So if I do my color coding here, we've got 6 and negative y, and they're separated by that plus sign. And then we have x squared plus 1 and x squared plus 1. So what is in common is the x squared plus 1. So our GCF is x squared plus 1. So we're going to factor that out. So that's going to go in front, x squared plus 1. And then you're going to have each term, so the 6 times x squared plus 1 divided by that GCF, x squared plus 1. Plus, so there's always a plus in the middle here, and then minus y times x squared plus 1 divided by x squared plus 1. So there's a pattern that you're following, especially when you're color coding here. So I'm just going to continue my color coding so you can see how the pattern gets laid out, because this pattern happens no matter what it looks like, whatever you're factoring. So everything that's x squared plus 1, I'm coloring it green so you can see that pattern. You're going to see that those cancel out. And then what was in front is 6 and negative y. And so, oops, I accidentally put green, then blue there instead of green. Okay. So we're canceling out the x squared plus 1s inside the parentheses. That's the simplify step. Is those basically we're dividing them out, so those get canceled. And so then we are left with x squared plus 1. And then 6, is everything else canceled, plus negative y. And that's your answer. So if we're doing our highlighting here, you've got your GCF in front. And then in the second set of parentheses, you have 6 plus negative y. So if you see this pattern, you can go from the very first step that they give us, and you can go to the final answer because you can see the pattern of what it's going to look like and where your things go. Okay, so here, all we're told is to factor, but this, it means the same thing. When you factor, the first thing you do is factor out the greatest common factor, which is going to be what's in common, the w squared minus 2. So all of these directions seem different, but they're all telling you to do the same thing. So let's look at what is in common here that we can see in the parentheses. It's w squared minus 2. Both of them have a w squared minus 2. Now, if you look in front, we have an 8v, but then we don't have anything in front of this second set of parentheses. So this is where it's very helpful to rewrite the problem and then put 1s if you need to. So I'm going to rewrite this so that's 8v times w squared minus 2 plus, and then I'm just going to put a 1 in front of the set of parentheses, because when you multiply by 1, you're not actually changing anything. So I can put a 1 there and it still means the same thing. And this will allow me to see the pattern. So we have our greatest common factor, which is the thing that's in parentheses that matches. And then in front, we have an 8v and a 1. So if we're following the pattern and seeing how this ends up with the color coding, we can skip this middle term where we're doing all the division and everything like that. We can skip it and go straight to the answer. So in front, we always have that binomial factor, w squared minus 2. So that part in green always goes front. And then the second set of parentheses is the stuff in blue with a plus in between your two things, 8v plus 1. So again, if we're following the color coding, the GCF, what's in common, always goes in front. Then you have your set of parentheses. And then what's in front of those things, what's left over, goes in the back. The 8v plus 1. And it's the same pattern that we saw here. And the same pattern, if I can get it there, same pattern here. So we had 13 and minus 4b. Those ended up in the back, and in front we had a plus 6. So it's the same answer. So you see the pattern, and you don't have to show all of this extra work. You basically can do it in like 1 or 2 steps. That's why I'm doing all this color coding, is so you can really see that pattern, and it will save you a lot of work, a lot of steps. But if you want to understand what's going on, you know, the dividing and everything, that's what we're doing here. It just, you can do it without having to actually write those steps. So here's another one. We're told to factor. So again, this means we're going to be looking for what's in common to try to factor it out. And we've got t times r plus 2 plus nothing in front, and then 2 plus r. Now notice, this is a little different, but notice that the r plus 2 and 2 plus r are almost exactly the same. They're just in a different order. The order of addition doesn't matter. That's that commutative property. So we can rewrite this so that they do match. So I have my t, and usually we put the variable first. So we're going to leave it as r plus 2. Then I have my plus sign. I don't have a number in front of the parentheses, so I'm going to add a 1. And then instead of writing 2 plus r, I'm going to write r plus 2. That means the same thing. We've just now rewritten it so that we can see that we do have pieces that match. We do have a binomial factor here, r plus 2. And that they do indeed match, even if it didn't initially look like they do. So you can see that your greatest common factor is going to be r plus 2, and then what's basically left over is going to be the t plus 1. So when I write this, I'm going to have r plus 2, and then when I remove that, I've got t plus 1. Oops, I did not mean to accidentally erase that. So you've got your r plus 2, and then what was in front, t plus 1. That's what we have next, is the second set of parentheses. Okay, so this is my last example. And so again, we're just told a factor, but that means we're going to be factoring out the greatest common factor, which is going to be a binomial factor. We have 5 times y minus 2, then minus 7y, then times 2 minus y. So right now in the parentheses, we do not have things that match. We have y minus 2 and 2 minus y. So let's start off by doing what we did on the previous problem, which is rewriting everything. So I've got 5, and I'm going to rewrite all of my subtractions as adding a negative. So that's really y plus negative 2. And then instead of minus 7y, that's going to be plus negative 7y. And then I'm rewriting this as 2 plus negative y. So by rewriting it that way, all my subtractions as a negative, you can see that my signs in the parentheses are kind of off. I've got a negative in front of the 2, but then I have a negative in front of the y. They don't match. But let's start by just rearranging it like we did before, flip-flopping. So I have 5 times y plus negative 2 plus negative 7y, and then this is a negative y plus 2. So now they're in the same order, but they still don't quite match because the signs are off. So when that happens, we do a little trick where you basically are factoring out a negative 1. So you're going to be dividing each of these by negative 1, and then you're going to be multiplying by negative 1 for the part that's in front there. And what this does, we're multiplying and dividing by negative 1, which is just the cancels out. We're not really changing anything, but this will get the signs to match. So we'll have 5 times y plus negative 2 plus, and then you have a negative 7y times negative 1. So now it's going to be a positive 7y. And then you have a negative y divided by negative 1. That's going to become a positive y plus 2 divided by negative 1 is negative 2. And so what we basically did is we just factored out a negative 1, and we did it so that now we do have a binomial factor, and you can see that it matches. So we had to do some manipulation because we almost had something that was the same, but not quite. So now that we have something the same, now we can use our pattern, because now we have the same thing in parentheses, and then we have things that are in front, and those are going to be our leftovers. So now I can go to the step where I'm actually factoring. So I'm going to have y plus -2, because that's the greatest common factor. And then in parentheses, it's going to be the leftovers. In blue, 5 plus 7y. So just color coding. The blue always ends up sort of in the back. And then in the front is our greatest common factor, y plus -2. So this example is a really good example to show why I always turn my subtractions into adding a negative, because it allows you to really see that you have the wrong signs, because we originally had y plus -2 and then 2 plus -y. The wrong things were negative. It also makes it easier when you have to factor out that negative so that you can keep track of your negative signs. Because now we're not subtracting a 7y, it becomes adding a 7y because we had a negative times a negative. So it also helps in that step when we're dividing and multiplying by -1 in order to get to the correct signs. So those are the two reasons why I always write my subtractions as adding a negative. And then once we got everything set up, then it was just, your typical steps from there. So just to kind of recap here, so step 1 is to turn subtraction into adding a negative. That was the first step we did. Step 2, we use the commutative property to flip-flop the second set of parentheses so that we had the y and the number 2 in the correct places. And then we factored out a -1, and that's what allowed us to switch the signs so that the signs matched. And then the last step we did was factor out the binomial factor. So there were several steps that we had to take here in order to get it to the right form so that we could factor. So that's part of what factoring means, and that's why a lot of the directions don't just say factor out a binomial factor. They just say factor, because there are often a lot of things you need to do along the way to get it to a point where you can factor out the binomial factor or factor out the greatest common factor. And all of these things you do along the way are part of the factoring process. So hopefully these examples were helpful. Once you watch this, you should be in good shape to watch videos on factoring by grouping and factoring by the AC method. So those would be the two videos that I would go to next. So I hope you're having a great day, and I will see you later. Bye.